Okay. Um, so solving quadratics is what we're going to be doing now. All right. And in the past, we've only been able to solve things that are to the first power. Now we're going to solve things that are to the second power. And believe it or not, you can solve an equation with any power. All right, but in the past, we've only known how to do something if it has just an x in it. So what we're going to do today is we're going to learn how to solve these equations. All right. Now, one of the fundamental theorems of algebra is the exponent will tell you how many solutions there are. So if something has a second power, there's going to be two solutions. If something has a third power, it will have three, and so on. All right. So today, very easy, especially if you know how to factor. For those of you guys who struggle a little bit with factoring, you have another 3 days to figure it out. All right. But let's talk about how to solve. All right. The first thing I want to write up here on the note is something very simple, and I want someone to tell me what your idea is. If I were to say this, if I were to say xy equals 0, what is true?
One of them.
Exactly correct. One of them has to be 0. Do they both have to be 0?
No.
Can they both be 0?
Yes.
Yes. All right, but one of them has to be 0. All right. So again, keep that in mind. All right, as we go through these. All right. Now, again, you have a quadratic. So your first thing you're going to do is you're just going to factor it. All right. So let's practice the factoring. All right. When you're doing the factoring here, you're going to do, again, 2 sets of parentheses. And those of you guys from the other class, I don't know if I've explained this. I'm not sure. I think Miss Pliego and I do it the same way. But generally, it's guessing and checking. All right. The only way we can make 2x squared is with what? 2x and x. All right. And now I want to make 7. So visually, I'm trying to show kids if I put a 5 there, that's going to create a what? A 10, which is too much. All right. So I want you at this stage of the game to try to visualize things. All right. And notice if I put the 5 there and I put the 1 over here, my smiley faces create a 5 and a 2, which means I can have what?
7.
If they're both what?
Positive.
If they're both positive. All right. So again, that's nothing new. All right, that is nothing new. Do you may have any questions on how to factor? All right. So now, again, this leads me back to what I tried to say in the beginning of class, is that I have 2 factors. So what has to be true? One of those factors is 0. All right. So now how do I figure that out? All you're doing is you're literally taking 2x plus 5 and saying that equals 0, or x plus 1 has to equal 0. Is everybody good with that? And now from there, you're just solving those equations. Now, I'm not expecting you to solve them. I'm just expecting you, or everybody should be able to just say x is equal to negative 5 halves, or x is equal to what? Negative 1. Yes, ma'am. Good for you. I just subtracted 5 from both sides and divided by 2, right? I took this equation right here, and I subtracted 5, and then I divided by 2. Everybody should be able to see that, right? Is that agreed? Just like this over here, all I did was I do what? Subtract 1 from both sides. Those are your answers. Now let me answer your question in 1 second. All right, so now, what do you suppose is going to happen if I replace the x with negative 5 halves? Guess what? That equals 0. All right? What happens if I plug in negative 1? It will be 0. All right, is everybody with me on this? All right, that's how simple it is. Very, very, very simple. All right, yes.
How you got negative 5.
All right, so I'll go slower. 2x plus 5 equals 0. Minus 5 minus 5. 2x equals negative 5. Divide by 2, divide by 2. X equals negative 5 halves. Or you can just look at it and say negative 5 halves. That's where you should be. All right, everybody should be able to solve a two-step equation in your head. Everybody. All right, especially one that deals with 0.
How does it equal 0? Like, how do you do that? I mean, it says equals 0.
Okay, so I think what I want to do is I want to go ahead and show her that it does equal 0 because I like people who can't quite see it. All right, and the reason why most people can't see it is because what's involved? Fractions. All right, so what I want to do now is I want to go through and I want to solve it with the fractions. And I would like everybody in here to review your fractions. ERBs are coming up in a month, or not a month, of 4 weeks, or whatever it is. And you're going to be expected to do fractions. It's been a while. All right? Now, one method is you can just type it into your calculator. All right? But another method is to just, you know how to do fractions. So let's look at it real quick. So if I square, remember, I have to do this first. So if I square that, that's 25 fourths. Everybody agree with that? So then it's going to be 25 fourths. I'm going to multiply that by 2 minus 35 halves plus 5. That should equal 0. Doesn't look like it yet, but let's see. Now, when I multiply 2 times 25 fourths, I can reduce that to 25 halves. Does everybody agree with that? Everybody good? Now I have, I'm just going to get rid of this. Now I have 25 halves minus 35 halves plus 5. That becomes negative 10 halves plus 5. And guess what negative 5 plus 5?
0.
So it doesn't look like it's 0, but it is 0. All right, if you know how to do fractions. All right, what?
Wait, why can't you change it to 25 halves? Why didn't you change the numerator?
You're asking me how to multiply fractions
No,
now.
up there.
Yeah, no, you're asking me how to multiply fractions. 2 times 25 over 4. What do you want to do?
Like, you made it 25 halves, but
What do you want it to be?
I see there's a 1 under the 2. I know.
So you haven't reduced 1 and 2 before?
Yes, I'm sorry.
Is that good now or not? All right. So again, honestly, this part of the reason why I'm doing it. Part of the reason why I'm doing it. You should be excellent at fractions. I know it's been a while. All right. Yes.
Could you plug in the negative 1 too?
Yes. If you plug in negative 1, guess what? You get 0. Do you want me to do it, or did you do it?
No, I didn't do it.
Yeah. So again, the nice thing about it right now is that you can plug it into your you can plug it into your calculator and you can see that it's 0. But again, negative 1, if you're plugging in negative 1, that shouldn't be a big deal. So again, just to make sure, 2 times negative 1 squared plus 7 times negative 1 plus 5, is that 0? Well, what is negative 1 squared? 1. 1 times 2, 2 minus 7 plus 5. Guess what? 0. So those are both of the answers. The reason why those are both the answers is because I just checked. All right, I just checked. All right, does anybody have any questions? All right, again, the principle is factor, set the factors equal to 0, and then solve. That's the rule. All right, so here we go. Let's take a look now at question number 3, just going down the page. All right, again, you should be pretty good at the factoring. If not, all right, you're making a good observation. Huh. I don't know what you're doing. Where's your iPad?
I don't really get it right now.
No, I understand that. Where's your iPad? Get it out. All right, open it up
Yeah,
and
no, I have it. It's just,
put it up there so I can make sure. All right, here we go. Now, again, we're factoring 2x squared plus x minus 6. All right, again, I think if I'm not mistaken, I just pulled these right off the last worksheet that we did. So it's probably not even the first time you've done these. All right. So again, I need 2x squared. We're doing 2x and x. Now, the factors of 6, 3 and 2. Again, we talked about 2 has to go on the right and 3 has to go on the left. For those of you guys who are still unsure, again, I always tell kids make your little smiley faces and you can kind of see the relationship. 4x and 3x makes 1x if the 4 is what? Positive and the 3 is negative. All right. The next step from there is to set the factors equal to 0. So we're going 2x minus 3 equals 0, x plus 2 equals 0. And then again, Maxine, do you agree this time you know how to do the two-step equations? So we're saying after that, I'm just expecting everybody to write x is equal to 3 halves or x can equal what? Negative 2. Anybody need me to go any slower on the factoring? Or does anybody want me to review the factoring? Good.
So together, you did like plus 3.
And then divided by 2.
Okay.
That's exactly right. Practice that now. All right? Yes.
So all you need for your answer is like factoring and the x equals 3 times positive. You actually have to solve it out.
Well, remember, this is what I was trying to tell you. I'm expecting my Algebra 1 kids at this late stage in the year to be able to look at 2x minus 3 equals 0 and just say x equals 3 halves. If you want to put the plus 3, divide by 2, feel free. It's not necessary. If you can't solve a two-step equation, you probably can't factor. All right? That's just the way it is. All right? So again, I'm on question number 5. We're just going down the page. All right? For number 5, again, this one should be pretty easy because, again, the leading coefficient is prime. So the only way we can make 3x squared is with what? 3x and x. And the only way to make 1 is with 1 and 1. And they're both positive, so the factors both have to be positive. All right? And now we set the factors equal to 0. 3x plus 1 equals 0. X plus 1 equals 0. So x equals negative 1/3 or x equals negative 1. All right, now I've done pretty much 3 examples. All right, right now you should be able to tell me you're getting the hang of it. All right, and I'm telling you it's not difficult. It really isn't difficult. Those of you guys who struggled with factoring, it's good that we're doing it again because I'm just showing you how to factor again. That's it. All right? All right. So now, number 7 is a little bit more difficult because the y squared is not in front, but it is negative. All right? So again, not too bad. All right? So here we go, 2 sets of parentheses. Factors of 10 that make 3. Good job. And then I want y. Now, the reason why it's a little bit trickier is because you have to make sure that you get the right negative in the right spot. All right? So this is what? 2y, correct? Do I want the 2y to be positive or negative?
Positive.
I want it to be positive. Now, to get the positive 2y, the plus goes there. All right? And I want the 5y to be what? Negative. So the minus sign goes there. All right? Now we're setting the factors equal to 0. 5 plus y equals 0, 2 minus y equals 0. So y equals -5 or y equals 2. Yes, ma'am.
Why didn't you just change the y and put it in front?
Actually, I could have done that. But if I put it in the front, it would be -y squared. Do you agree? Now, let me show you another technique. Because it's equal to 0, I recommend this to some kids because I do think the -y squared is harder. I can, watch, take this and move it to the other side. If I move it to the other side, it's going to be what? Positive. So I have y squared. Now I have to move this, which is going to be what? Positive 3y. And then I move this, which is going to make it what? Now watch. If I factor this, it comes out to be y plus 5, y minus 2, y plus 5 equals 0, y minus 2 equals 0, y equals -5, or y equals 2. You see what I'm saying now? So it doesn't matter. Do you agree with me? But you can't just put the y squared in front because it still makes it -y squared. Do you agree with that? But if you move it to the other side of the equation, all right? Now I want to try to emphasize this to you guys. This right here, the 10 minus 3y minus y squared, all right, is different than y squared plus 3y minus 10. It's different by a factor of -1. Or it's different by a factor of -1. All right? Yes.
You said that y equals +2, but why would it be -2?
Very good question. So watch and listen. Here's how your brain should be seeing this. You ready? Watch. I'm taking this because it's negative and I'm moving it over here. And when I move it over there, it becomes what? You understand me now?
I thought that you improved the y.
Don't think that anymore. You can move anything. All right. Here we go. Number 9. Let's see how things are going. All right. On number 9 now. 2 sets of parentheses. 3x and x. Now, where does the 5 go, on the right or the left? To the right, correct? Very good, because I want it to be 16. And so you should see and visualize that as 15, right? And the 1 goes here. They're both negative because I want it to be -16. Now listen, I'm trying to tell you, this is just a great continuation because if you struggle a little bit with factoring, I'm just explaining factoring again. That's it. That's why this is a really good lesson. All right? So if you're not sure about the factoring, now's the time, put your hand up in the air and say, give me a little bit of help. Pickens, you okay? No excuses. Now, you set the factors equal to 0. Now, at some point in the game, I don't even care if you put that step down. Right? I mean, I just think everybody from that step, everybody should just say x equals what? 1/3 or x equals 5. Does everybody understand what I'm saying? All right. But again, most of your teachers, especially next year, if you were going to do that, they'd freak out on you. All right, because they want you to show the work. So you would have to put down what? 3x minus 1 equals 0, x minus. Does everybody understand what I'm saying?
Yeah.
Right? If you can skip that step, feel free. But you don't want to make you don't want to make careless mistakes. So if you need to write that step down to visualize it, do that quickly.
How do you know if it's going to be 1/3? When is it a fraction? When is it?
Yeah, okay, so here's what I need to show you. Connor, look real quick now. All right, this is something I want you to think about, all right, when you're solving this problem. I add 1, do you agree? So I get 3x equals 1, do you agree with that? Now, a lot of kids make the mistake and they just put 3 down, right? But we're isolating the x. That means we're dividing by 3, which shows you that it is a fraction. All right? You with me now? All right? So if you're unsure about that, you got to practice 3 or 4 times before you see it. But most kids put 3 down. Yes.
Why is that one negative? That's not negative one.
Because, again, watch this. All right? This had to be moved over here. Right?
Oh, yeah.
And when I move something, I have to do what to the sign? Switch the sign. That's all there is to it. All right? I think it's good, guys, and I really am serious now. I really don't care what you're, even if it's adding and subtracting fractions and multiplying fractions, and sometimes, you just forgot a few things. Or fix it now because we have another quiz on Thursday or on Friday. All right? It's very simple. All right? If you can factor, it's going to be really simple. All right? What? Yes. Now, this one, though, however, I do want to start out, why is this one really hard? Because there's a lot of factors of what? 36, and there's a lot of factors of, but if you paid attention to me, you know that you can't have common factors in the same set of parentheses. So, you ready? Tell me what you're thinking. What did you want to break it down to first?
6x plus.
Now, right off the bat, I can tell you're wrong. You with me on this? And the reason why I know that's wrong, try to listen to what I'm saying. That's going to help you out tremendously. This right here, there's a factor of 2, and there's a factor of 2 there.
Oh,
So they cannot be together.
so it'd be 9.
So I know 6 and 6 is out of the question. All right, I know 6 and 6 is out of the question. So instead of trying 6 and 6, I'm going to try,
9 and 4.
let's try 9 and 4. All right, so here we go. So we're going to try 9x, and we're going to try 4x. And now, factors of 24 that we're going to try. Now, listen, 6 and 4 is the common one. All right, but does 6 work? No, there's nowhere to put the 6. And I want to show you this. 6 doesn't go there because there's a common 3. If I put 6 over here, there's going to be a common 2. So you know that doesn't work. So we're going to try. Now we're going to try 8 and 3. So where does the 8 have to go? On the left. And the 3 has to go on the... Now obviously I'm not saying she's correct. But we'll check and see. 8 times 4. 9 times 3. 27 and 32 make 5.
27.
If the 27 is negative and the 32 is positive. Now again, we took something very difficult and made it super easy because we knew you couldn't have common factors. All right? In each group of factors. Michael, does that make sense now? All right. Now, in my opinion, all right, I want you to make sure you have this equal to 0. Now, the next step, I would just say you can just write the answer. Now, this is a good review, Connor, of your fractions. So the first one, x equals. So you visualize moving the 8, and then what? Dividing by 9. So if I move the 8, it becomes, and then when I divide by 9, it creates the fraction. Come on, that's simple. Simple. All right? Visualize moving the 3, it becomes what? So x equals 3. And then I divide it by 4, which creates the fraction. Simple as that. All right, not a difficult task. All right. Now, let's take a look at 13. Good problem. All right, what do I notice here? Yep, they already have it grouped for us. So we're factoring out a what?
X minus 3.
We're factoring out an x minus 3. And what's left behind?
X plus 5.
Very good. So x is equal to
3.
or
X is equal to
x is equal to -5. Thank you. It's not difficult. All right. Those are your two solutions. All right. Now what I want to do is I want to look on question number 15. Somebody tell me how many solutions there are going to be.
5.
Connor, how many solutions? Why?
I don't know. I just saw the first one.
Nope.
Because
Or is it
Oh.
Yeah, look at the exponent. There are 3 solutions. There are 3 solutions because the exponent is 3. If the exponent is 4, there would be 4 solutions. All right? So now, what is the rule when you see 4 terms? Factor by grouping. Factor by grouping. All right? So when you factor by grouping, let's review. All right? You're taking the first 2 and the second 2, and you're grouping them together. All right? And you're saying, what's common with x cubed and x squared?
X squared.
There's a common x squared. And what's left behind? X plus 1. Now, what's common in the next 2?
-4.
Now remember, when you factor out a negative, you change the signs. I factor out a -4, I'm left with?
X plus 1.
I'm left with x plus 1.
Why is it x plus 1?
You're dividing by -4. Dividing by -4.
How'd you get plus 1 on the first one?
X on the first one?
Yeah, 'cause
Okay, now, the reason why, again, because you're dividing. If I say x squared and divided by x squared, what is that? There you go. All right, if you pull something out, nothing remains, it's a 1 because you are dividing. All right, so now what's common? The x plus 1, and what's left behind?
X squared minus 4.
And now what can I do with x squared minus 4?
You can factor that.
Thank you very much. So I factor that to what?
X plus 2x minus 2.
Very good. X plus 2, x minus 2 equals 0. Now, do you see it has 3 factors? Therefore, you can see the 3 what? Solutions. All right? So your 3 solutions are x equals what? Or x equals, or x equals positive 2. Now, what does that mean? That means if I plug in -1, what am I going to get? If I plug in -2, if I plug in 2, those are the only 3 numbers, all right, that if you substitute them in will give you a 0.
How does it correlate with x cubed? Like, how does x cubed impact how many terms?
Well, just because we know it's going to factor into 3 different sets.
What if it was x to the 4th?
Somebody said, what if it was x to the 4th? Then you could factor it how many times?
4 times.
4 times. And x to the 5th, 5 times. All right. And then at that stage, we're getting into algebra 2, but that's all there is. All right. Yes.
how did you know to like choose the x cubed instead of x?
Because it's the largest exponent. It's always the largest exponent. All right, here we go. Let's check out 17. All right, is this factor by grouping?
No.
No, but there is a common factor. There is a common factor, which is x. So we're going to pull out the x. What is left behind?
X squared minus 2x minus 4.
Beautiful. Okay. X squared minus 2x minus 24 equals 0. All right. Now what we're doing is we're taking this and we're factoring that. Now notice I've already pulled out the what? The x. So don't drop that. That's where people make their mistakes. They forget that they factored out an x. So that's x. Now we have 2 sets of parentheses. What are the factors of 24 that make 2? That's all right. 6, -6, and a positive 4. Okay? Anybody have any questions with that? Now you're setting how many factors are there?
3.
Equal to 0. So x can be 0, or x can be 6, or x can be -4. Now, hopefully you understand why 0 is logical, because 0 cubed is 0. 2 times 0 squared is 0. 24 times 0 is, everything is a 0. Good for you.
So the x equals 0, you got that outside of the parentheses?
Well, actually, it occurred from here. Please watch. This right here, I set that equal to 0. I set this equal to 0, and I set this equal to 0. When I solve those, that's how I get this, that's how I get this, and that's how I get this.
Oh, so it's basically just saying like -6 plus 6 is equal to 0.
I couldn't have said it better myself. Now you're thinking. Feels good, doesn't it? Honestly. Can't help if you're not asking questions.
So, like, when there's like a thing outside of the box, like, you know how there's the X on this one?
When there's a factor,
When there's a factor outside of the parentheses, then it has to have 3 solutions, right?
well, what gives it 3 solutions is this right here.
Oh, yeah.
The exponent is 3, so I had to find 3. Okay?
Why do you do x equals 0? Because that's probably sort of the problem spelled it.
Well, is there a x outside the parentheses? No, so
Why isn't there?
because we didn't factor out an x. An x isn't common. There isn't an x in all 4 of those terms. There isn't an x in all of the terms.
When you like factor out x and number 17, and you have to have 3 solutions, won't always come to 3.
Well, what I'm trying to do now, Marilyn, is do you see how that's logical, right? If you put a 0 in for x, you're multiplying everything by what? 0. So it has to be what? That makes sense, right? Okay. All right. Now, what's common in number 19?
2x.
A 2x. Don't forget, there's a common 2. All right. Now, we don't want to factor out a negative because the leading coefficient is positive, right? So we're going to factor out a 2x. Remember what the rule is. You divide numbers, subtract exponents. So 3x squared minus 1. Do you agree with that? All right. Now we're factoring 2x. So we have 3x and x. 1, 1, 1 and 3. Negatives where?
On the right.
Oh, yeah. Negatives on the right. All right. Everybody see that? Now again, James's mistake is the common mistake. It's the common mistake because you want it to be negative, you put the negative with the 3. But that's not what we're doing. Come on.
The one you just did, I put that first. I didn't even do 2x.
Well, then you did it wrong.
3x squared
Well, then you did it
minus-
wrong. All right, now listen. What I'm trying to say, Jack, look up, please. What I'm trying to get you to realize is that you have to look at those 3 first and say, is there anything common? Every single time you try to factor out a GCF. Every single time. All right, is there anything common? That's your first step, always. All right, and there was a common 2x. All right, now you should be able to tell me x equals 0 or x equals -1/3 or x equals 1. Everybody good with that?
How do you get x equals 0?
Well, if I set 2x equal to 0, what is x? 2 times what is 0?
0.
There you go.
Wait. So, I also don't know how it would be 2x equals 0 instead of just x.
It is 2x equals 0. 100% correct. So solve that equation.
Oh,
What times 2 is 0?
0.
That's why it's 0.
But, okay, never mind.
You with me?
Yes.
All right? You're literally setting all 3 of those factors equal to 0 and solving. And those of you guys who are having trouble, you're looking at me like 2x equals 0. You're having trouble solving that. You with me? All right, put a star by number 21. I want to tell you something about 21. All right, on question number 21, is there something common?
Yes.
Is there a common x?
No.
No, so listen to what I'm saying. You got to be smart now. You got to hear me. Does it make sense to say 3 equals 0? No, it would not make sense to do that. All right, so what I want to try to show you is if ever you have something just a constant, you divide out that constant. Notice I'm not dividing by x. I'm dividing by 3. Now, why is that a legal move? Because 0 divided by 3 is still what? It's still 0. All right? So when I divide by 3, I end up with x squared plus 4x plus 4 equals 0. All right? Now we're going to factor this into x plus 2 and x plus 2. So x equals what? Good. X equals negative 2. And negative 2, I want you to put in parentheses, is called a double root. All right, now why do we call it a double root? Because I said there were 2 solutions. It's just this same solution occurs how many times? It occurs twice. So x equals negative 2 or x equals negative 2. It's not necessary to write x equals negative 2 or x equals negative 2. What?
Why can't you just do like 3x?
Because you always want to divide out the greatest common factor. All right? Now, put a star by number 23. Kids always have trouble with these. I probably should have put these first. But the point is they're already what? They're already factored for us. They are already factored for us. So all you have to do is say,
X equals 0.
or,
X equals 6.
that's it. X equals 0 or x equals 6. All right? Just like on 25, you should be able to now say x equals 5 over 2, or x is equal to 1/3. That's how simple. All right, anybody have any questions? Yes.
I have a question on 23. I don't understand how you want x equals 0.
I put this factor and set it equal to 0. See how that is? X equals 0. All right, here we go, guys. Number 27. All right, now we're back to just the normal factoring, which should be very basic for you. Factors of 18 that make negative 7. Exactly. And so here we have x equals 9, or you're right, x equals negative 2. Any issues? All right, so let's take a look at 29. How do I factor x squared minus 25? Beautiful. X minus 5, x plus 5. So x is equal to 5, or x is equal to negative 5. Anybody have any issues with that? Any issues? Okay. All right, a couple more to go. All right. Now, here, do I want to break 2 and 2 up, or do I recognize that 9 and 4 makes what? 13. Does everybody see that? All right. 9 and 4 makes 13. So we don't really want to break up the 4. We can just write it as what? Yeah, that's right. 4x and x. And 9 must go on the left. All right. And 1 would go on the right, and they both would be negative. All right. Again, because we want to be negative 13. So now you set them equal to 0. 4x minus 9 equals 0. X minus 1 equals 0. So x equals 9/4, or x equals 1. All right, somebody tell me what's wrong with 33. Right, it's not set equal to 0. All right, so the only thing you have to do now is you have to make it equal to 0 by moving the 6 over. So it's not a big deal. It would just be 2x squared plus x minus 6 equals 0. All right? Because it's positive 6 on the right. Move it to the left, it's negative. All right, now we're going to factor this. Again, 2x and x, 3 and 2 plus minus. All right? And so now set the factors equal to 0. So x is equal to 3 over 2, or x is equal to negative 2. And last one for the day. Well, actually, not the last one. All right, 35. All right, again, let's try to get this done quickly. 4x and 3x, 4 and 2. Not going to work. So it's going to be 8 and 1, correct? So 8 would have to go over here, 1 here. And the reason that works again, negative 3 and negative 32 makes negative 35. Come on, just continue to work to the end. Set them equal to 0. 4x minus 1 equals 0. 3x minus 8 equals 0. So x equals 1/4, or x equals 8/3. All right.
So you move the 1 over, or the 4x minus 1, you move 1 over, it becomes positive. But when you move the 4 over,
You're dividing, not moving. Okay, now 37 is the one that is hard. All right. Now the reason why I would say it's hard is because, first of all, it's not set up in the right format. It's not set up as a quadratic. So I have to actually physically multiply this together first. Come on, Jack, pay attention here. All right. So it's going to be x squared. Now remember, that's negative 3 and positive 8, which gives me a positive 5x, and then negative 24 equals negative 30. Does everybody hear me on that? Now you have to set it equal to 0 by what? Adding 30 to both sides. When I add 30 to both sides, you should be able to tell me x squared plus 5x plus 6 equals 0. And now you're back in action. All right? Now you can factor this easily. X plus 3, x plus 2. Exactly correct. All right? So that's considered the hard one because you have to multiply it together first. Then you have to set it equal to 0. All right? So hopefully you understand what I'm saying now is I want everybody to do the evens now. Don't get into the word problems. We'll try to knock out the word problems tomorrow. But listen carefully again. If you can factor, this wasn't difficult. All right, great job today, guys.